Hey, so I'm going to try to go over a couple questions up here for you and kind of remind you how we solve these. So when we look at this question, the first thing I notice is that it's not equal to 0. So I'm going to add 1 to both sides, where I will get 2 sine squared x plus 3 sine x plus 1 equals 0. Once it's equal to 0, we can now solve, because I notice this is a squared. So this is, again, like having 2x squared plus 3x plus 1. So when we look at this, you're going to factor. If you remember, we went over this. You do 2 times 1, and I would get 2. So I have sine squared x plus 3 sine x plus 2. Then we factor. I know the only things that give me 2 are 1 and 2, and that will give me 2a3. Again, this is still all equal to 0, but remember what we talked about when we factor these. You then have to come back and divide by 2. So this would leave me at sine x plus 1/2 and sine x plus 1. So really, when these are equal to 0, this is asking when is sine x equal to negative 1/2, and when is sine x equal to negative 1. So again, at this point, this is when you just go to your unit circle. They asked for us in radians. I know that sine is negative 1 at 3 pi over 2. So there's one of my answers. And then I look for when is sine negative 1/2. Well, that would be in the 4th quadrant and the 3rd quadrant. So it's negative 1/2 at 7 pi over 6. And it's also there at 11 pi over 6. So again, you're taking into account some things we've already done in class, and you're now just applying them to actually solve for these questions. So you had 3 answers for this one. If we keep going, and we'll try to skip around some because a lot of these are the same. So let's do this one. I did do this one in class, but again, it can be a little tricky. And I do it a little bit differently than how MyLabs Plus does this question. So when I see a double angle, I immediately want to get rid of it. So cosine double angle, I know, is cosine squared minus sine squared. And then I still have sine up there, right? So that's what I just turned this whole thing into. Now to counteract that, so we can get some of these squareds kind of out of the way, I know that 1 is sine squared plus cosine squared. Remember the Pythagorean. Again, sine squared plus cosine squared equals 1. So I actually am bringing that into this problem. And once I do that, again, remember you want these equal to 0. So I'm going to subtract both of these over. And we're going to see something that happens. So when I subtract this one, the cosines will cancel. I will end up with negative 2 sine squared minus sine. And this will all be equal to 0. So again, once you're equal to 0, this is when we can try to think about how we can solve this. Now this one doesn't have, another number at the end where we can factor, but I can take a GCF out. I could take out a sine. So they both have sine on them, so this would be negative 2 sine minus 1. And then I want to set each one of those equal to 0. So sine equals 0. And then I also have negative 2 sine minus 1 equals 0. So again, you're solving, add 1. I would then divide by negative 2. So again, you're looking when sine is equal to negative 1/2. Now, the negative 1/2 is exactly what you just did. So we would have the 11 pi over 6, and then we would also have the 7 pi over 6. So we just found those a second ago. Now, when sine is 0, I know that happens at 0, and that happens at pi. And you can kind of double check these a little bit as far as what you're looking for based on the graph. The graph will kind of help you. So like if we go look at the graph, you can see where the red line and the blue line hits. I know it crosses right there at pi and it crosses at 0. So that's how these answers work. And then 11 pi over 6 and 7 pi over 6, you can kind of get some estimates here about where they show. Now it's a little bit harder to see it on the graph, but the work definitely applies. Let's try to do, that's the same thing that we just did. Let's see, try one more. Let's do this one since we don't have, if we haven't done one with secant and technically tangent yet. So in this case, again, we want it equal to 0, so that's not going to do a whole lot for us to start with. So I'm going to go ahead and move that -2 over. So we will have that 0 value, so I'd have secant squared minus 2 tan equals negative, oops, sorry, I said I moved it, but I didn't. Plus 2 equals 0. Now the only thing that's going to mess us up here is that none of these are the same. So we need to have the same trig functions. So I'm actually going to change secant because that's a Pythagorean. I know secant squared is equal to 1 plus tangent squared. So I'm going to do that. So 1 plus tangent squared minus 2 tangent squared plus 2 equals 0. So let's try to do just some basic algebra. So like terms, tangent squared, that's 1 minus 2. So I'd have negative tangent squared. It's like saying, x squared minus 2x squared. I know that's just negative x squared. That's how I'm getting that. I'm just putting the like terms together. And then I notice that I have 1 and 2 together. So that's plus 3. All of this equals 0. So when I try to solve this, I then just have to try to, break it down, see what we can actually do. So I would actually have to take, and again, solve this for 0. So I would subtract my 3 over, -3, and then I would divide by -1. So tangent squared x equals 3, and then remember to get rid of that, you have to take the square root. So I finally get tangent of x equals plus or minus the square root of 3. Now, again, this is something that's pretty common. We've seen this a whole lot now, as far as how do we find tangent is square root of 3? Remember, that's when you have square root of 3 over 2 over 1/2, because the 2's would cancel. So remember, again, this is also sine over cosine. So when is sine square root of 3 over 2 and cosine 1/2? Okay, so that happens at pi over 3. And since this is plus or minus, you're going to write all of them. So technically, every value on your unit circle that has a 3 on the bottom is actually going to work. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Again, all of those will work. So there's 3 of them. Try to do the other 2 yourself. But let me know if you have any more questions about them.